I'm going to try to make this one a quick one. I'm going to be solving this problem in 3 different paradigms. So, problem statement goes, you need to return a string that gives you the position of every letter in your input string. They are going to be space separated and it's going to be a string. So first up, C. So I kind of practiced this ahead of time, but still going to be difficult. So we do our standard includes SCT lib age, include C type. We're going to be needing C type or character typing, and then also of course string age. So for C, we're going to be doing a bit of assumptions, so it's much easier for me to do. So here's our input. What was it? Sunset sets at 12 o'clock. So this is our input. And then our solution here, oh, I forgot the name. Int. And then for our solution here, we'll just call it, it'll return a car star, and then it'll be solution. And it'll take in a const car star input. And okay, we're ahead of the curve right now. So why is this complaining? Brackets are supposed to be here. So first of all, we're going to make our return, of course. So it will be a car ret. It's equal to. Then we have to allocate. Let's just say it's the length of our input times 3. That should be big enough. So our main assumption here is that we will be dynamically allocating our string, and then the caller will free. That's pretty standard assumption. So here we'll have car star result is equal to solution int, and then we do a printf s on result. Then of course we free result. Okay, back to our solution. So, well, for convenience, let's make a pointer here for r. Just point it to the start of r, and then we'll have an index I, started at -1 for convenience, and this index we'll be using to read from input, because you can't really dereference and move an increment input because it's constant, right? So you're gonna be using indices. So let's do a while input and then I plus plus I. So that's why we started at -1, so we can leave the increment inside here, and it'll be much tertiary inside. So how this would go is we will be doing an sprintf, and what this does is you give it a pointer and then it'll write over there using a formatted string. So we'll just format our int I, and then that's pretty much it. But first we have to check if int I is an alphabet. So it's in alphabet, so we just do is alpha there, and then now we have to move our RP by how many letters we put in. And so sprintf actually returns that, so it's pretty convenient. So we can just do RP plus equals there, and because all of these are in like one line, so we can just remove the braces in a while, and that will be much cleaner. So last, of course, we have to put on the last index we have to return our null terminator, and we just return ret, and I think that should be it. GCC imperative, let's see. We are very much off because I forgot to do operations. So we we lower this to lower, or is it too lower? It's too lower, and then we subtract it from lowercase a and +1, and then 28,520. That's the answer. Okay, quickly, we move on to Python. We'll do functional on Python. Functional is just means that your solution will be composition of functions. So let's do def solution, and what is it called? And then here in the front we'll do this. So do 6j, and then all input is equal to that, and then print solution input. So for solution, all we have to do here is first we can lower. If we give this a type hint str, it will help us. So we can do an int lower, and that would lowercase all of our inputs. And then for every single one of those, we can do x. We can do a compare here. We can do x for x in, and the reason we're doing this is so that we can do our operations here. So it's going to be ORed x minus ORed a plus 1, and then we turn that into a string. Then of course we have to filter alphabets. We do an if here. If if x is x is alpha, x is alpha. Yeah, x is alpha. Okay, go. So then this will return us an array, right? So functional.py. Yeah. So all we have to do now is we join them on spaces. That is it. Okay. Lastly, we go on to APL, or our array paradigm. Okay, here we are in dialog, right? So first of all, we'll clear our workspace, and then we'll get our input, and it should be sunset sets at 12 o'clock. And then to escape this, we double it up, so we have high now, sunset sets at 1 o'clock. And then we have a few functions in APL that goes like this. Square C will lowercase everything, and if we do one square C, it'll uppercase it. If we bind it, that will make it clearer. So next up is, the reason we're uppercasing it is so that we can apply it to we can apply element on it with the alphabet, the uppercase alphabet, and the uppercase alphabet is this. So if I type out LA, that would give me A, B, C, D, E, F, G, F. And if we get the element, like membership of that, then we get a Boolean mask, and we can use that to compress over our original array, and we'll get that. And then afterwards, we just index it with the alphabet, and then we get its positions in the alphabet. And APL is one indexed, so it works perfectly for this situation. And then we turn it into a string using thorn. This one, thorn. Where is it? This one, thorn. Format. And we'll know this is a string because we can't add a number on it. Yeah, domain error. So we can bind this to. Oh, no, not that. We can bind this to F. Except I should not have given this I. So it should just be, let's bind it to G. And it's going to give us a syntax error because this isn't a proper function right now. And to make it idiomatic, we'll be doing trains here. So first of all, we'll turn this into parentheses, and then I will tell APL that this function on the left should occur after the right. So now we don't have access to omega or our parameters, so we can remove all of that. We bind this to A, and then we compress over it using this that compress. We flip it around, and we have to introduce these two new characters, and this is identity. Right tag is identity, so the result of this function will be passed here in the identity, and then this will compress over the result of using identity on this, which is because of this is an S combinator right now from combinatory logic. Then afterwards, we're gonna do an index of in A alphabet, and then we do a thorn, and and then this should work. Will and yeah, that's it. 3 different paradigms. Thank you.